Trigonometry is a branch of mathematics that focuses on the study of triangles and the relationships between their sides and angles. There are 6 trigonometric functions that represent the ratios of the sides of a right triangle. A ratio is a comparison between two numbers. For example, if we compare the number 2 to 3, we can express it in 3 different ways. We can write 2 to 3. We can write the two numbers with a colon in between them, or we can write our ratios as a fraction. For trigonometric functions, we express our ratios as fractions. So for example, if one of the sides of this triangle has a length of 2 and another side has a length of 3, we're going to compare those two sides by writing them as the fraction 2 over 3. Now, how do you express which sides of a triangle to compare, and which number to write on the top of the fraction and which number to write on the bottom of the fraction? Let's take a look at the 6 trigonometric functions. Each trigonometric function is comparing two sides of a right triangle. A right triangle is a triangle that has a 90-degree angle. The 6 trigonometric functions are sine, cosine, tangent, cosecant, secant, and cotangent. In this lesson, we're only going to be focusing on the first 3 trigonometric functions: sine, cosine, and tangent. But you'll be able to easily understand cosecant, secant, and cotangent by applying the same exact concepts that you'll learn in this lesson. In math problems, you're usually going to see the abbreviations of those names. So the abbreviation for sine is SIN, cosine is COS, tangent is TAN, cosecant is CSC, secant is SEC, and cotangent is COT. The letter A that you see after the abbreviation is referring to this angle that we're using in order to find our trigonometric ratios in this right triangle that is shown. Now, the letter A is shown here just as an example. The letter pictured here could be any letter of the alphabet, and it's always going to be the letter of the angle that we're using to find our trigonometric ratios. The angle that we use to find our trigonometric ratios could be angle A, or we can also use angle B. It can be either one of these angles. You may also see letters from the Greek alphabet used to represent the angles. For example, the Greek letter theta is one that is commonly used in trigonometry problems. The angles used will be one of the 2 acute angles in a right triangle, either angle A or angle B, but it'll never be from the point of view of angle C. The reason why we would not use the point of view of our 90-degree angle to find our trigonometric ratios is because we will be labeling each side of our triangle as the hypotenuse side, the opposite side, and the adjacent side. If we were to look at our triangle from the point of view of our 90-degree angle, then the hypotenuse side would also be considered the opposite side, and the remaining 2 sides would both be considered the adjacent sides, and that would not work with our system, which requires each side to have only one label that applies to it. This brings us to the final part of our trigonometric functions. The fraction part is telling us which 2 sides we are going to compare by expressing them as a ratio in fraction form. Let's take a look at how we're going to label each of the 3 sides of our triangle. We're going to assign a specific name for each side of our triangle. One side is the hypotenuse, another side will be the opposite, and the third side will be the adjacent. We're going to look at our triangle from the point of view of angle A. In a right triangle, the side across from the 90-degree angle is always the hypotenuse. The side across from angle A is the opposite side. The remaining side is the adjacent side. The word adjacent means next to, so the adjacent side is one of the sides that forms angle A along with the other side that is touching angle A, which is the hypotenuse. To find the sine of A, we're going to divide the opposite side by the hypotenuse side. To find the cosine of A, we're going to divide the adjacent side by the hypotenuse side. And to find the tangent of A, we're going to divide the opposite side by the adjacent side. It is highly recommended that you memorize which sides you divide for the sine, cosine, and tangent functions. One way that you can memorize them is by using the mnemonic SO, CA, TOA. The SOH stands for sine, opposite, hypotenuse. The CAH stands for cosine, adjacent, hypotenuse. And the TOA stands for tangent, opposite, adjacent. Most students will just naturally memorize the functions through repetition of practice problems, but some students may benefit from using this mnemonic. In example 1, we have to find the sine, cosine, and tangent of angle A. That means we have to look at our triangle from the point of view of angle A. We'll begin by correctly labeling each of our 3 sides. The side across from our 90-degree angle is the hypotenuse. The side across from angle A is the opposite side. The remaining side is our adjacent side. To find the sine ratio of angle A, we have to divide the opposite side by the hypotenuse. The opposite side has a length of 24. The hypotenuse has a length of 40. So let's write that in fraction form, 24 over 40. Now in math, we always have to simplify our answers. So we could simplify our fraction by dividing our numerator and denominator by 8. This gives us 3 over 5. This is our simplified answer in fraction form. Now if you want our answer in decimal form, we divide 3 by 5 and that gives us 0.6. So 3 over 5 is our simplified answer in fraction form and 0.6 is our answer in decimal form. Now let's find the cosine of A. In order to find the cosine ratio of angle A, we have to divide the adjacent side by the hypotenuse side. Our adjacent side is 32 and our hypotenuse is 40. Let's put that in fraction form. So we have 32 over 40. We simplify our fraction by dividing the numerator and denominator by 8, and that gives us our simplified answer in fraction form, which is 4 over 5. In order to get our answer in decimal form, we divide 4 by 5 and that gives us 0.8. Now let's find the tangent of A. To find our tangent ratio of angle A, we need to divide the opposite side by the adjacent side. The opposite side is 24, the adjacent side is 32. So we have 24 over 32. This fraction can be simplified by dividing our numerator and denominator by 8, which gives us our simplified answer in fraction form, which is 3 over 4. Divide 3 by 4 in order to change the ratio to decimal form, and that gives us an answer of 0.75. That's basically all there is to it. In example 2, we have the exact same triangle, but now we have to find the sine, cosine, and tangent of angle B. So we're going to do the exact same thing that we did in example 1, but from the point of view of angle B. Let's start by labeling each of our 3 sides. Our hypotenuse is always the side across from the 90-degree angle. That does not change. The side across from angle B is our opposite side. The remaining side, which is touching angle B, is our adjacent side. Notice that the hypotenuse is still the same, but the opposite and adjacent sides have switched places because we switched from angle A to angle B. Okay, now let's find the sine, cosine, and tangent of angle B. To find sine B, we divide the opposite side by the hypotenuse side. The opposite side is 32, the hypotenuse side is 40, so that gives us the fraction 32 over 40. We simplify our fraction by dividing the numerator and denominator by 8, which gives us our simplified answer in fraction form, which is 4 over 5. To get our answer in decimal form, we divide 4 by 5 and that gives us 0.8. To find the cosine of B, we divide the adjacent side by the hypotenuse. The adjacent side is 24, the hypotenuse side is 40, so we have 24 over 40. We simplify by dividing our numerator and denominator by 8, and our simplified answer in fraction form is 3 over 5. To write our answer in decimal form, we divide 3 by 5 and that gives us 0.6. To find the tangent of angle B, we divide the opposite side by the adjacent side. The opposite side is 32 and the adjacent side is 24, so 32 over 24. We simplify by dividing our numerator and denominator by 8, and our simplified answer in fraction form is 4 over 3. To write our answer in decimal form, we divide 4 by 3 and that gives us approximately 1.33. Now I want to point out a very important relationship that exists between angles A and B. When we looked at our triangle from the point of view of angle A, in order to get the sine of A, we divided the opposite side by the hypotenuse side, which gave us 24 over 40. We simplified that and got 3 over 5 or 0.6. Now when we switched over to angle B, our adjacent and opposite sides switched places. And to find the cosine of b, we divided the adjacent side by the hypotenuse side. So we divided the exact same sides, 24 over 40, which simplified to 3 over 5 or 0.6. So when we get the ratio for the sine of a or the cosine of b, we divide the exact same sides and we get the exact same answers. Now let's look at what happens when we get the cosine of a. In order to get the cosine of a, we divide the adjacent side by the hypotenuse side. That's 32 over 40. We simplify our fraction and we get 4 over 5 or 0.8 as a decimal. When we switch to angle b, our opposite and adjacent sides switch places. To find the sine of b, we divide the opposite side by the hypotenuse side. So once again, our fraction is 32 over 40, which simplifies to 4 over 5 or 0.8 as a decimal. So when we get the ratio for the cosine of a or the sine of b, we end up dividing the exact same sides and getting the exact same answers. This brings us to this very important relationship. The sine of a will always equal the cosine of b, and the cosine of a will always equal the sine of b. Keep in mind the letters a and b are just variables representing the two acute angles in a right triangle. This relationship that sine and cosine have make them co-functions. Secant and cosecant are also co-functions, and so are tangent and cotangent. Now, what does it mean to be a co-function? The co-function theorem states that a trigonometric function of an angle is always equal to the co-function of the complement of the angle. Let's go to example 3 so we can see what is meant by the co-function of the complement of the angle. Example 3. Express sine of 37 degrees in terms of cosine. What this means is that we are being asked to write an expression using cosine that is equivalent to the sine of 37 degrees. In our triangle, we can see that angle A is the 37-degree angle. We don't know what the measure of angle B is just yet, so let's figure that out. The sum of the interior angles of a triangle will always equal 180 degrees. So let's use that information to find the measure of angle B. Our triangle has a 37-degree angle and a 90-degree angle. Let's assign the variable x to the measure of angle B. Now, since the three angles have to add up to 180 degrees, let's write that in an equation. 37 plus 90 plus x equals 180. We combine the like terms on the left side of our equation, and that gives us 127 plus x equals 180. Now subtract 127 from both sides of the equation, and that leaves us with x is equal to 53 degrees. So the measure of angle B is 53 degrees. Now let me show you a faster way that we could have used to solve for the measure of angle B. As you can see, angles A and B are complementary angles. Complementary angles are two angles whose sum is equal to 90 degrees. This will always be the case in a right triangle. The two angles that are not 90 degrees must add up to 90 degrees in order for all three of them to add up to 180 degrees. The faster method of solving for angle B is to just subtract 90 degrees minus 37 degrees, and that gives you 53 degrees. Okay, so now that we know the measure of angle A and angle B, we can very easily answer our question. Since we learned in example 2 that the sine of A will always equal the cosine of B, the measure of angle A is 37 degrees and angle B has a measure of 53 degrees. So just substitute 37 and 53 for A and B, and that gives us sine of 37 degrees equals cosine of 53 degrees. Our answer is cosine 53 degrees. You can check this in your calculator. If you enter sine 37 degrees into your calculator, then enter cosine 53 degrees, you'll see that they both give you the same ratio, which is approximately 0.6. Example 4 is just like example 3, but now we're going to solve this problem the fast way. We have to express cosine of 20 degrees in terms of sine. So that means we have to write an expression using sine that is equivalent to the cosine of 20 degrees. We can see angle A is our 20-degree angle. Let's quickly solve for the measure of angle B. Since angles A and B are complementary, we can solve this very quickly and easily by doing 90 minus 20, and that gives us the measure of angle B, which is 70 degrees. Now, since we know that the cosine of A is equal to the sine of B, And since the measure of angle A is 20 degrees and angle B is 70 degrees, just substitute 20 and 70 for A and B, and that gives us the cosine of 20 degrees equals the sine of 70 degrees. So our answer is sine of 70 degrees. And just like I said in example 3, if you enter either cosine of 20 degrees or sine of 70 degrees in your calculator, they will both give you the same ratio, which is approximately 0.94. Let's take a moment to look at the cofunction theorem once again. A trigonometric function of an angle is always equal to the cofunction of the complement of the angle. So we have a right triangle pictured. The acute angles are 50 and 40 degrees. They are complementary angles. Since sine and cosine are co-functions, that means that the sine of 50 degrees will equal the cosine of 40 degrees, and the cosine of 50 degrees will equal the sine of 40 degrees. The same is true for the other two pairs of co-functions, secant and cosecant, and tangent and cotangent. Okay, in example 5, we have to find the sine, cosine, and tangent of angle D. Let's start by identifying our three sides. The side across from our 90-degree angle is the hypotenuse. The side across from angle D is our opposite side. The remaining side next to angle D is our adjacent side. To find the sine of D, we divide the opposite side by the hypotenuse side. So that's 30 over 34. We can simplify our fraction by dividing our numerator and denominator by 2, which will give us 15 over 17. That's our simplified answer in fraction form. In decimal form, we divide 15 by 17, and that gives us approximately 0.88. For cosine of D, we divide the adjacent side by the hypotenuse side, which gives us 16 over 34. We can simplify our fraction by dividing by 2, which gives us 8 over 17. And to get our answer in decimal form, we divide 8 by 17, and that gives us approximately 0.47. For the tangent of D, we divide the opposite side by the adjacent side, so that's 30 over 16. We simplify it by dividing by 2, which gives us 15 over 8. If we divide 15 by 8, we get our answer in decimal form, which is 1.875. In example 6, we have our same triangle from example 5, but now we're going to find the sine, cosine, and tangent ratio of angle F. The hypotenuse side is always across from the 90-degree angle. The side across from angle F is the opposite side. The remaining side is the adjacent side. We find the sine of F by dividing the opposite side by the hypotenuse side, which gives us 16 over 34. We simplify our fraction by dividing by 2, which gives us 8 over 17. We divide 8 by 17 to get our answer in decimal form, which is approximately 0.47. For the cosine of F, we divide the adjacent side by the hypotenuse, which gives us 30 over 34. We simplify it by dividing our numerator and denominator by 2, which gives us our simplified answer in fraction form, 15 over 17. We divide 15 by 17 to get our answer in decimal form, which is approximately 0.88. For the tangent of F, we divide the opposite side by the adjacent side, which is 16 over 30. We simplify by dividing by 2, which gives us 8 over 15. We divide 8 by 15 to get our answer in decimal form, which is approximately 0.53. Example 7 is similar to examples 3 and 4, but in example 7, we're not given a picture of the triangle. In example 7a, we have to express the sine of 68 degrees in terms of cosine. This is extremely fast and easy. Our answer will have cosine, and we have to find the complementary angle by subtracting 90 degrees minus 68 degrees, so that gives us our answer, which is cosine 22 degrees. You can check that this is true in your calculator. If you enter either sine of 68 degrees or cosine of 22 degrees, they both give you a ratio of approximately 0.93. In example 7b, we have to express the cosine of 52 degrees in terms of sine. So our answer will have sine, and we find the complementary angle to 52 degrees by subtracting 90 degrees minus 52 degrees. So our answer is sine of 38 degrees. And looking once again at our cofunctions, if you're given the sine of an angle and you have to express your answer in terms of cosine, you would write your answer as cosine and subtract the given angle from 90 degrees in order to find the measure of its complementary angle. If we're given the cosine of an angle, it will equal the sine of its complementary angle, which you can find by subtracting 90 minus the given angle. The same would apply to secant and cosecant and to tangent and cotangent. So we've covered sine, cosine, and tangent, But what about the 3 remaining trigonometric functions? If you look closely at what sides are being divided in each function, you can see that cosecant is the inverse of sine. In sine, you divide the opposite side by the hypotenuse. In cosecant, you just flip that upside down and divide the hypotenuse by the opposite side. Secant is the inverse of cosine. Cosine is the adjacent side divided by the hypotenuse. Secant is the same thing flipped upside down. The hypotenuse is divided by the adjacent side. Cotangent is the inverse of tangent. Tangent is the opposite side divided by the adjacent side. Cotangent is the adjacent side divided by the opposite side. Okay, now it's time to practice what you just learned. You'll need a paper, a pencil or a pen, and a calculator is recommended. You have 30 seconds to complete 4 practice problems. If you need additional time, just pause the video. Use the reference sheet to help you remember sine, cosine, and tangent. For problems number 1 and 2, you should write your answers as a simplified fraction and as a decimal. Round your decimals to the nearest hundredth if necessary. You may begin. Time's up. Let's go over the answers. For problem number 1, we begin by identifying the sides of our right triangle. For sine of A, we get 15 over 39. Simplify by dividing the numerator and denominator by 3, which gives us 5 over 13. Divide 5 by 13 and we get approximately 0.38. For cosine of A, we get 36 over 39. Simplify by dividing the numerator and denominator by 3, which gives us 12 over 13. Divide 12 by 13 and we get approximately 0.92. For tangent of A, we get 15 over 36. Simplify by dividing the numerator and denominator by 3, which gives us 5 over 12. Divide 5 by 12 and we get approximately 0.42. For problem number 2, we begin by identifying the sides of our right triangle. For sine of E, we get 48 over 50. Simplify by dividing the numerator and denominator by 2, which gives us 24 over 25. Divide 24 by 25 and we get 0.96. For cosine of E, we get 14 over 50. Simplify by dividing the numerator and denominator by 2, which gives us 7 over 25. Divide 7 by 25 and we get 0.28. For tangent of E, we get 48 over 14. Simplify by dividing the numerator and denominator by 2, which gives us 24 over 7. Divide 24 by 7 and we get approximately 3.43. Problem number 3. Express sine of 46 degrees in terms of cosine. So we write cosine and we subtract 90 minus 46 degrees to find the complementary angle of 46 degrees, and our answer is cosine of 44 degrees. Problem number 4. Express cosine of 12 degrees in terms of sine. So we write sine and we subtract 90 minus 12 degrees, and our answer will be sine of 78 degrees. Let us know in the comments how well you did. Make sure to check out more trigonometry videos on the Math Discipline channel. Thanks for watching.